them located between the back two wheels of a rear-wheel drive car. On a front-wheel drive car, we find it between the front two wheels, and we find one at the front and another at the rear of a four-wheel drive car. However, we're going to stick with a rear-wheel drive car in this video for simplicity. So why do we need it? When a car moves in a straight line, the engine provides power through the drive shaft into the differential, which divides the power between the two rear wheels. This propels the car along, and so the wheels will all rotate at the same time at the same speed. However, when a car turns, the front two wheels change direction, but the rear wheels remain in position. The wheels are now following different length paths. The inner path is shorter than the outer path. So the outer wheels must cover a longer distance in the same amount of time, and that means they need to rotate faster. So the rear wheels need to turn at different speeds. The differential allows the wheels to rotate at different speeds. If this wasn't installed, then both wheels would rotate at the same speed on corners, and this would cause the tires to slip and wear out. The car would become harder to handle, and the forces could even snap the axle. Therefore, we allow the rear wheels to rotate at different speeds to stop that occurring. We can see from this basic model differential that if I hold one of the wheels, the other can still rotate. This is known as an open differential. The problem we face is that if one of the wheels travels over a slippery surface, such as ice, almost all of the engine's power will transfer to the wheel with least resistance, and so the car becomes stuck. To solve that, we use a limited slip differential, and we will see how that works later on in this video. By the way, you can also learn how a car generates electricity in our detailed alternator video. Links down below for that. Let's look at the main parts of a rear differential. First, we find the main housing, which surrounds all the internal components. Somewhere on the casing, there will be a removable plate, allowing access to the internal gears. The casing stops debris from the road damaging the internal gears. It also retains oil within the housing to lubricate the gears and reduce wear. If we remove the housing, we can see the various gears which are attached to the axles. These are supported by a number of bearings to ensure a smooth rotation. The engine will provide power via the input gear, which is known as the drive pinion gear. The pinion gear connects to the ring gear, which is much larger. Notice the gears are